Okay? Okay, great. So this evening we'll take a little tour of God's creation, and tomorrow will be further topics on science and religion. So it's the kind of thing that I think about a lot, and I'd just like to share a few ideas with you. So for tonight, some trip through God's creation. We'll start out from the earth and move farther away. I have always been interested in astronomy, although I'm not an astronomer. I teach physics, but as a 10-year-old, I received a telescope kit for a present. It was like this, a Newtonian reflector mount, which means you don't have to have as long a scope because the light goes in, bounces off a mirror, and then comes back. And then you put your eyepiece at the side, as this picture shows. Well, as I say, it was a kit. When I put it together, I couldn't get it quite aligned, and I thought I was seeing the craters on the moon, but I think I was seeing the craters on the inside of the cardboard tube. But now I have access to some fancier scopes. We have two 20-inch Schmidt-Cassegrain telescopes in the physics department and one 35-inch. The Cassegrain mount has the light go 3 times through the barrel. So effectively, it's 3 times longer, and you can collect a whole lot of light. So, as mentioned, I teach physics at Southern Adventist University, and my brother-in-law was just asking me to figure out, we have now been there 21 years. That's hard to believe because I just graduated from academy. I don't understand how this could happen. So we think about stars. And when astronomy, everybody first says stars and constellations. So you may recognize Orion, the Big Dipper, Cassiopeia, but actually that's not where we should start because these groups of stars are not even together. It's just from our angle, these stars seem to be close together. And that's not a real star group. So some stars seem bright because they're close to us, and others seem bright because they actually are huge. You go to the foot of Orion, you see a very bright star. That's Sirius, the dog star. It's bright for 2 reasons. It's much, much bigger than our sun, and also it's quite close to us, only about 5 light years away. So for 2 reasons, that, if you don't count the planets, that's the brightest thing in the sky. Well, sun, the moon, the planets, and then Sirius is the brightest star. You can see it at the foot of Orion. But although constellations don't really mean anything because one star may be close to us and one far away, and they just seem to line up, it's helpful for identifying stars. So many of you know that if you line up the 2 stars at the edge of the Big Dipper, it points to the North Pole star, the pole star, Polaris. And there are other tricks like that you can learn. But the true group of stars is a galaxy, a group of stars. So we're going to go there. Let's start with what is a star, and then we'll move out. So a star, we have a real good example of one, our sun. And we'll show you a couple pictures with different filters on the scope. You don't just aim your scope at the sun, it would burn it out. And don't aim your eye at the sun either, it'll burn it out. So a few different filters, and if you zoom in, you can see the sunspots. The sunspots, the black areas, are colder than the rest of the surface. The surface is about 6,000 degrees Kelvin, and the sunspots are maybe only 5,000. So you'll still burn up in a flash, but much cooler. So these sunspots come and go. There's an 11-year cycle where we have more sunspots and then less. Any ham operators know that more or less sunspots affect the signal of your ham radio, and so we're aware of those cycles. The sunspots also help us see that the sun is rotating. So you can track the sunspots as they move around as the sun spins. However, it's not like the Earth, it's not solid. The sun has some parts that are spinning faster than others. So it goes between 25 and 35 days to make one complete cycle, depending where you are. If you zoom in on the surface, the sun shows a mottled appearance. And again, that color represents heat, or what's the warmer or colder. So what do you think? Would the yellow spots be hotter and the red colder, or vice versa? What do you think? Think the yellow's hotter or colder? Hotter? Okay, we got some votes here. Colder? Okay, hotter is right. And again, it's all way too hot for us to visit, but we can zoom in with our scopes and our filters and get a good look. And that's where hot material rises, just like hot water rising when you boil a pot of water. So that's convection. In the center of the sun, nuclear fusion is what's operating, what's generating the heat. It's 15 million degrees in there. So 6,000 at the surface doesn't sound so bad after all. And again, the sunspots are cooler. Okay, so nuclear fusion is combining hydrogen to make helium, and in the process releases tons of energy. It's like an H-bomb, is what it is, except constantly releasing energy. And that energy flows out. It takes hundreds of years to reach the surface by radiation and also by stirring, by convection. And then when it reaches the photosphere, it comes to us through empty space. This animation on the left is an eclipse where the moon blocks the sun, and then we can get a good look at some of that surface. This is called the chromosphere because it's colored instead of just white. The sun is so bright that normally it just looks white to us. Put the moon in front, and it almost exactly covers. That's a coincidence, or maybe God set up a nice show for us to see. And then the surface has all sorts of irregularities, spicules, and jets of gas. And these things we can see with different filters. So quite a different view of the sun from what you're used to seeing. The one on the right is an X-ray picture. The sun is putting out X-rays, puts out radio waves. It puts out heat and ultraviolet and everything. And on the left, we have the corona of the sun, which you can only see during an eclipse because the rest of the sun is blacked out, and then we can see the faint crown. So all stars are like this, but maybe some are much bigger. So these jets of gases pouring out into space. Oh, and just for comparison, this little spot here is, it's not showing. Little spot is the size, where the arrow shows is the size of the Earth. So the sun is huge, and yet it's a fairly small star. And this one is, I think, an X-ray image also. You can see where some of the material of the sun can be shot out into space. And that would reach the Earth a few days later, and it would kill us all. Except we have our own Earth has a magnetic field that guides the radiation away from us. And that's where we get the northern lights, the aurora borealis, northern and southern lights. So things are set up, designed for us to live. And that's something that we see over and over in science. God planned things to make life possible. Okay. And it's not just what you see, but the invisible, from Colossians 1:16 and 17. For in him all things were created, things in heaven and on earth, visible and invisible, thrones or powers or rulers or authorities, all things have been created through him and for him. He is before all things, and in him all things hold together. I tell my classes, we look at nature to see the artistry of the divine artist. We see his signature, his way of creating. It's amazing. Okay, so from the sun, we'll move out. The planets, you know that the sun has planets going around it. We're sitting on one. It's interesting that all these planets are sort of in a pancake, in a flat. It's called the ecliptic. It's like a sheet of paper. They're all orbiting around in circles. You'd expect some of them to go another way, but no, they're laid out, and we'll do a quick visit of some of these. So, by the way, Pluto is not quite in the plane, in the same orbit as the rest of the planets. Maybe that's one reason we demoted it. It's no longer considered a planet. So, the size of the different planets to scale, and now we'll take a little trip through. Oh, I should mention, the outer planets are made of hydrogen and helium gas. Inner planets, hard, rocky things, and maybe some ice. Especially the smaller satellites may be icy instead of rocky. So they're never lined up like this, but they're orbiting around. So let's start with Mercury. Looks a lot like the moon. Crater covered. Hot because it's close to the sun. And the next one out will be Venus. So just for comparison, Earth is sitting there next to Venus. You can see they're about the same size. And the lower picture shows a flyover, and we have sent missions to Venus. Many people in this country don't realize that the Russians put a lander on Venus before the Americans did. And any lander on Venus can only last a few hours before the intense heat ruins it. Venus is hotter than Mercury because of the runaway greenhouse effect. The thick clouds over Venus hold in the heat, and there is no ocean. It boiled away, and it's just water and carbon dioxide in the atmosphere. Have you ever seen a very bright star at sunrise or sunset, just before the sun rises, after the sun sets? It's probably Venus. It's the morning star, the evening star, not both at once. I like to look for Venus if soon after sundown, because Venus is nearer to the sun than we are, so it's going to follow the sun closely. But soon after sundown, take a look for a bright star over near where the sun set. Same thing in the morning. And it's going to be the brightest thing in the sky. These pictures are if we stripped away the clouds and looked at it, looked at the surface. Not a good place to live. Then we move out. Mars, also rocky, hard desert, smaller than Earth, but there's a plan to put people on Mars. You can sign up for it, manned mission to Mars, but it's a one-way trip right now. So if you put your name on that list, they're not doing a round trip. They're asking for settlers. And believe it or not, they have about 100 times more people signed up than can be accepted. So we'll see how that works out. Mars has the longest crater that we've ever seen, the Valles Marineris, and it also has the biggest mountain, the biggest volcano we've ever seen, Olympus Mons, inactive volcano. Then we move out to Jupiter, huge compared to the Earth. There in the little picture, Jupiter, we could just drop the Earth in. In fact, drop it into the Great Red Spot, which is a hurricane storm. Here's Jupiter with some of its moons. Has 50-odd moons, but here's some of the large ones. And one of the animations shows one of the moons, Io. The middle one shows the Great Red Spot spinning. And this is just a gigantic planet-wide storm. And then we move to Saturn. I've always liked Saturn. You can actually see the rings even with a small telescope. And you get a better scope, you can see fine detail in the rings. You see the black line between the rings? That's the Cassini division. When we first sent the Voyager spacecraft to do a flyby, some of the scientists in the project wanted to send Voyager through the Cassini break and see what it looked like there. They decided not to do that after all, and it's a good thing, because there's rock there too. The rings are made of rock and ice, and we would have crashed. Even though it's dark, it's not empty. It turns out all of the outer planets have rings. Who knew? But the Voyagers and later missions have shown these. So beyond Saturn, we go to Uranus and Neptune, sometimes called twins. Neptune is the windiest place we've ever seen, cold and very, very windy. And then other things. Pluto is now considered a dwarf planet. You can be very glad of this because otherwise we'd be memorizing 30 planets today. We've found a lot of dwarf planets, and they're not really planet-worthy. So we'll just call them all dwarfs. And these are, for instance, Makemake and Sirius, Eris, lots of these, which are smaller than real planets. Then we have asteroids, which could be very irregular, and comets. Comets are dirty snowballs, frozen ice, and as the sun shines on them, it sort of melts and makes the tail. And you could even see two tails, perhaps, at times, one from the ionized gases and one from just the water and dust that is blown off it. Here's the comet Hale-Bopp, two clear tails, one ionized that moves in the magnetic field, turns, and one that is just neutral material. And the solar system is more than we realized. There's the Oort cloud, the Kuiper belt, and these are places where our comets are formed and then drop in and we see them. So Kuiper belt, Oort cloud, and these are all bigger and bigger, farther away. If we get farther away from our star, we'll see other stars, and we'll also see nebulas. I have some nice pictures of nebulas I hope you like. Nebulas are clouds of dust and gas. So they're still inside our galaxy, but they're not inside our solar system. So we've gone away from the sun, but we're still inside our collection of stars in our galaxy. So here's a nebula picture. I'll just run a few of these. The light bouncing off these, or some of them glow with different colors. It's just amazing, beautiful pictures of clouds of interstellar gas. And you just have a huge variety. This is the Keyhole Nebula. And then this is M16. Some of these are taken by the Hubble Space Telescope, which was our very best instrument. Now it's being decommissioned, and we're going to have the James Webb Telescope, which will be even better. Orion Nebula. And this is the Horsehead Nebula, also in Orion. Many of these pictures I got offline, I got from the internet. Just do a search for APOD, that's Astronomy Picture of the Day. Some very beautiful shots. Many of them by the Hubble Space Telescope. So here is the Elephant's Trunk Nebula. I'm not quite sure where's the elephant's trunk in it. Is it the pointy thing in the middle? You need a little bit of an imagination. Spirograph Nebula. Did you play with a spirograph when you were young? One of these things. It makes all these cool patterns. It really does look like but this is a planetary system that exploded. So it left gas and dust around. So some nebulas are just gas and dust that are kind of floating around, and some are remnants of an explosion. They're also still inside our galaxy. We know about black holes. You can't see them directly, but you can see their effects. It's a little bit like the Spirit. You don't see, but you see the effects. So what we've got here, now this is an artist's conception, but a large star on the left, and then some of the matter is being sucked off and disappearing. And we can measure this. We can measure the radiation that's emitted, but it's just going into an empty spot, and there's nothing there that we can see. And that's because the black hole is so massively gravitationally attractive, it'll pull everything in, even light. And so it's black. We don't see any light out. And nothing that goes in ever comes out. So black hole is a pretty good term for this. This one is Cygnus X1, which was our first confirmed black hole. It emits X-rays, not the black hole itself, but the matter that's being sucked in, sort of like a death scream as it disappears into the black hole. Okay, when we get beyond, we'll see the galaxy. Our galaxy is Milky Way, yes, very good. And there are billions of stars in the average galaxy, and there are billions of galaxies in the universe. So we're just one of many again. This image shows, this one shows the Hubble classification, different types of galaxies. Scientists like to try to give names or find patterns, and so we have some elliptical galaxies, we have some spiral galaxies, and then barred spiral. In fact, Milky Way is now considered to be a barred spiral. When I was a kid, it was called a spiral galaxy. And then there are irregulars, so don't fit in with these others. But the pattern is intriguing. Why are some galaxies clumped together in one way and others in another? And we really don't know many of the answers yet. We're still studying, still trying to figure out. Beautiful shot of Andromeda. This is one of the galaxies you can actually see with binoculars, if you know where to look. And it looks like a smudge, but when you look through a good scope, it looks just like the Milky Way, except a little bigger. It's maybe our big sister. A little bit bigger, but very similar to the Milky Way. And a few other galaxies. Now this is an interesting shot. If you look at the kind of irregular line shape or curve on the right side, that's a galaxy looked at end on. And you say, wait a minute, I thought they were kind of flat. A spiral galaxy would be kind of flat if we look at it sideways. Well, this is looking at it sideways, but the light is bent going by a massive black hole or some other large mass, and so it's coming at us from an angle that is based on the curvature of space. So it looks deformed even though it's really flat. So that is an interesting idea. That really is flat, but we're seeing it in a different place. Two galaxies colliding. Here are galaxies already in the process of colliding. Now, actually, the stars in the galaxies will just pass right by each other and have no effect at all. So it's not a collision like you should worry about. And this is one of my favorite pictures, although I have to explain it to you. This is the Hubble Ultra Deep Field. There's a certain place you can aim your scope, and you'll see it's in the constellation Sagittarius. And in a range that's only less than a degree across, we see millions of galaxies in this direction. The universe is full of galaxies, but in this direction there are a lot that are close enough for us to see. So every spot on that picture, whether it's a big spot, you can say, oh yeah, that's a galaxy, or just a spot of light, that's a galaxy. 100 billion stars. Makes you feel kind of small, doesn't it? So here, galactic clusters. Okay, this is a cluster of galaxies, and then two clusters colliding. So where does it go from there? You have stars that make up galaxies, and galaxies cluster together to make galactic clusters. And then there are superclusters, which would be clusters of galaxies, of stars. Where does it end? Is the universe infinite? Does it go on forever? It's possible. We can't see more than the reach of our telescopes. But it's another possibility to think about is the universe might be finite. Let me explain. If you walk north, well, let's say, forget the ocean, but you're going to just keep walking in a straight line, and you never turn. If you come to the North Pole, eventually, you're going to keep going in a straight line. What happens now? We can't go north anymore because you passed the North Pole. Now which way are you going? You're going south, even though you're going in a straight line. And if you keep going south, you'll get to the South Pole. And then if you keep going, there's no edge to fall off. So this is an unbounded path that you have. There's no bounds, there's no end. But it's not infinite either, right? It doesn't go on forever and ever. Neither do you come to the edge of the earth and fall off. Now, one interesting, intriguing possibility is the universe is like this too. You could go as far as you want, in any direction you want, and eventually you'd be back to where you started. Very interesting thought. Or let's take our strongest telescope, and we'll look farther and farther away until we see the back of our head. Well, of course, not really, because light takes a long time to travel. We think of light as fast, but the universe is so immensely huge that it would take billions of years for the light to travel. And if we had more time, I could talk about the billions of years. Many people are uncomfortable with the idea that the universe is so big and light could travel for this immense period. But I hope that throughout all eternity, we'll be experiencing billions of years. And also, I don't know if God did other creation before our world. God is a creative God. So some answers we'll have to wait for heaven. Genesis is pretty clear that life on earth is recent, and I think we can rely on that. But I think God may have been creating also forever. So if we took our most powerful telescope and if we could actually see around the universe, we would not see the back of our head, but we would see the place where we are standing now as it was billions of years ago. Or if time goes on and God doesn't just recreate the whole universe, which is also a possibility, we'll see how these things develop. So, infinite or finite? I don't know. But we do know a lot about the universe as a whole. This is the image of the cosmic microwave background radiation, which comes to us from all parts of the universe. It's not stars, it's not galaxies, but it's just low-grade radiation in the microwave region, which is coming from all parts of the sky. This looks like it's a flash from all around us. I think of Genesis 1 where God says, "Let there be light," and there's light. Today the universe is expanding. It's getting bigger. And so what used to be light gets stretched into radio waves, gets stretched into microwaves. This is what we're seeing. We're seeing the remnants of the flash. Whether or not the universe is infinite, it is immense. And the fact that God can care about each of us, number the hairs on our head. For some of us, he's having an easier job now, not so many to count. But our God is more awesome than the universe he created, obviously. The Creator is infinite, whether or not the universe is. He is infinite. He is infinitely powerful. He is outside his creation, and he can step in any place, any time. But he is not limited to this space. The universe, no matter how awesome it is, God is more. As we consider his creation, as we consider what we can understand about God, our attitude should be to worship. We should be amazed. We should be full of awe. I think of the famous line by the astronomer Johannes Kepler, who was the first to understand the paths of the planets. He said, "I feel carried away and possessed by an unutterable rapture over the divine spectacle of heavenly harmony." We see how God, like a human architect, approached the founding of the world according to order and rule. Kepler didn't know the half of it, but we see that order and pattern and rule and the design everywhere we look. Or to go back a little farther, in the words of David, "Lord, our Lord, how majestic is your name in all the earth. You have set your glory in the heavens. When I consider your heavens, the work of your fingers, the moon and the stars, which you have set in place. What is man that you are mindful of him, and the Son of Man that you care for him? Let's pray. Lord, we are amazed. We stand in awe of the creation, the part of the creation that we can see. But we know that your power overshadows everything in this amazing universe. And you have chosen not only to work wonders, but also to work miracles in our lives. You want us to spend time with you. We thank you for the Sabbath hours that you've set aside especially for this purpose. And we thank you that you have made it possible for us to understand some of your amazing creation. We give you the praise. Amen. I've got lots more pictures, but I figured just a taste is better than overload. Thanks.